Russia has just declassified images that have been hidden for over 50 years, revealing what they show about Venus. These aren't just any photographs. They are the first and only images ever captured from the surface of another planet by human technology, taken by Soviet missions. Let's uncover leaked images that reveal the shocking discoveries that the Soviet Union kept hidden from the world for decades. While America was focused on putting a man on the moon, the Soviet Union was quietly attempting something far more technically challenging. The 1960s and 70s marked a dramatic period in the history of space exploration. It was a completely new frontier, and learning how to create machines that could survive in harsh, unknown environments pushed the limits of human engineering. Nations like the United States and the Soviet Union were caught up in the space race, sending missions into space not only to demonstrate their technological strength but also out of concern that space might one day become a new arena for conflict. For the Soviet Union, one of the earliest major goals was not Mars or the Moon, but Venus. Venus was closer to Earth during certain orbital windows, making it a more achievable target than Mars. More importantly, Venus was completely unknown. Its thick cloud cover meant that no telescope on Earth could see its surface. If the Soviets could successfully land there and send back data, they would achieve something unprecedented in human history, the first direct observations from the surface of another planet. Unlike NASA's very public missions, the Soviet space program operated under a veil of complete classification. Sputnik was the first attempt by the Soviet Union to send a flyby probe to Venus. While NASA was concentrating on Mars and other planets, the Russians dedicated their efforts to studying Venus, and this mission marked the beginning of that journey. The launch took place on February 4, 1961, but unfortunately the spacecraft never made it beyond Earth's orbit. You won't find Sputnik in most space history books because officially, it didn't exist. This pattern of secrecy meant that the true scope of Soviet ambition remained hidden for decades. The exact reason for the failure remains unclear, but it may have been due to the design of the Tyazdeli Sputnik, which means heavy satellite. Although this spacecraft, also called Venera-1 did not succeed, it gave scientists valuable lessons on how to improve future missions. Just 9 days later, the Soviets made another attempt. This time, they launched Venera-1, which managed to leave Earth's orbit and set a path toward Venus. Sadly, a few months before the expected flyby, radio communication was lost, and no data could be received. This marked the beginning of a series of difficulties for the Venera program. After that, 2 more missions from the 2MV1 series reached Earth's orbit but failed to break free because of engine problems, eventually falling back to the planet. Things got worse when the third stage of the rocket carrying Venera-2 number 1 exploded during flight, destroying the probe. The Soviets launched 2 more spacecraft soon after, but both also failed to leave orbit and ended up crashing back to Earth. By 1965, they were ready to make another attempt. This time, Venera-2 reached Venus successfully, but communication was lost again before any data could be transmitted. Next came Venera-3, which made it into Venus's atmosphere before contact was lost. Despite that, it technically became the first human-made object to reach the surface of another planet, though it crash-landed instead of making a soft landing. It was far from a perfect success, but it still marked a historic achievement. Later that same year, another Venera probe ended in failure, crashing somewhere in Pennsylvania. After years of catastrophic failures, Venera-4 finally achieved something remarkable. In 1967, Venera-4 featured a 3.5-meter main spacecraft carrying a 383-kilogram descent probe with scientific instruments inside a pressure-resistant shell. Launched on June 12, 1967, from Tyazdeli Sputnik, it adjusted its course on July 29 and entered the night side of Venus's atmosphere on October 18, 1967. For the first time in human history, a spacecraft successfully transmitted data from the atmosphere of another planet. At about 52 kilometers altitude, a small drogue parachute deployed, followed by a larger main chute. 5 minutes later, instruments activated around 55 kilometers and operated for 93 minutes, collecting 23 readings before the probe failed. Under extreme pressure at 25 kilometers, the data showed Venus's atmosphere contained 90 to 95% carbon dioxide, no magnetic field or radiation belts, and traces of atomic hydrogen at high altitude. Though it lasted only 93 minutes, the mission was considered a major success. However, the Soviet scientists initially believed that Venera-4 had reached the surface of Venus. They announced to the world that they had successfully measured surface conditions on another planet. Only later did they realize that the probe had been crushed by atmospheric pressure. This meant that Venus was even more hostile than they had imagined. Two similar probes, Venera-5 and Venera-6, were launched just days apart in 1969. Built on the same design but stronger, each main spacecraft weighed 1,130 kilograms and carried a probe designed for rapid descent using smaller parachutes to collect data from deeper layers. Each probe included instruments such as thermometers, a barometer, gas analyzers, and light sensors. Venera-5 launched on January 5, 1969. Releasing its probe on May 16, it began transmitting after parachute deployment, sending data every 45 seconds for 53 minutes before succumbing to heat and pressure. It confirmed high temperatures, pressure, and carbon dioxide, similar to Venera-4. Venera-6 launched January 10 and released May 17, transmitted for 51 minutes before contact was lost at 10 to 12 kilometers. Though its light sensor failed, it measured pressure levels at 2 and 10 bar. Together, Venera-5 and 6 confirmed that Venus's atmosphere was too harsh for life and far denser than Earth's. Their findings mapped the planet's atmospheric structure, identified its cloud layers, and deepened scientific understanding of the greenhouse effect on Venus. If you like this video, be sure to subscribe and hit the bell so you don't miss any future episodes. Don't forget to share it with your friends too. It helps the channel out, and I'm excited to continue bringing you more awesome content. On August 17, 1970, the Soviet Union launched Venera-7. This mission was designed as a lander probe that would touch down on Venus and send data back to Earth. The descent module was built to make a soft landing, reinforced with thick protection to endure the planet's extreme surface conditions, even if only for a short time. Before entering Venus's atmosphere, the spacecraft was cooled to about -8 degrees Celsius. After using aerodynamic braking to slow down, the parachute deployed at around 60 kilometers altitude. The antenna extended, and signals began transmitting, but just 6 minutes later, the parachute tore apart and collapsed. The probe continued falling toward the surface for another 29 minutes. Upon impact, it hit the ground at about 17 meters per second, and the signal briefly weakened, then spiked for a second before almost disappearing. Later analysis revealed that Venera-7 had actually survived the landing and continued sending a faint signal for about 23 minutes. Scientists believe it may have bounced on impact and landed on its side, which caused the antenna to point away from Earth. At first it seemed the mission had failed, but the probe managed to return valuable data. It recorded a surface temperature of nearly 900 degrees Fahrenheit, or about 475 degrees Celsius, which is as hot as a brick oven. Although the pressure sensor malfunctioned during descent, researchers estimated surface pressure at around 92 bars, roughly equal to being 900 meters underwater. The next mission, Venera-8, was launched on March 27, 1972, and took 117 days to reach Venus. Before atmospheric entry, its interior was cooled to -15 degrees Celsius. As it descended, aerobraking slowed its speed, and instruments were activated at 50 kilometers altitude. The probe measured lower light levels and detected wind speeds under 1 kilometer per second below 10 kilometers. After landing, it continued sending data for 63 minutes before the heat and pressure caused it to fail. Venera-8 confirmed the high surface temperature and pressure first reported by Venera-7. It also measured the light levels, discovering that they were similar to an overcast day on Earth with about 1 kilometer of visibility. The probe returned the first measurements of Venus's surface soil and identified sulfuric acid in the planet's cloud layers. Its functioning pressure sensor verified the dense atmosphere and provided data that encouraged scientists to continue pursuing images of Venus's surface in future missions. This is where the story becomes absolutely incredible. Between 1975 and 1978, the Soviet Union achieved something that still seems like science fiction today. They successfully photographed the surface of another planet. Among all the Soviet missions to Venus, Venera-9 through Venera-12 remain the most well-known, mainly because their landers carried cameras that captured direct images of the planet's surface, offering humanity its first real glimpse of Earth's scorching twin. Some of the cameras failed due to their lens caps not releasing, but a few succeeded in transmitting the first photographs ever taken from the surface of another planet. The early images from Venera-9 and 10 appeared distorted because of their wide-angle lenses, yet they revealed a bleak, rocky world stretching to the horizon. Parts of the landers were visible in the frames, showcasing their distinct Soviet engineering style. Venera-9 launched on June 8, 1975, and touched down on Venus on October 22. Before descent, a circulating fluid system cooled the lander to -60°C, allowing it to operate for about 53 minutes after landing. The camera system was designed for a full 360-degree panorama but managed only a 180-degree image because one of the lens covers failed to release. Venera-9 became the first spacecraft to transmit photos from Venus's surface. Though the pictures were black and white, they showed a rugged, slab-filled landscape. Just days later, Venera-10 landed and sent back more images revealing a similar terrain. Both missions confirmed earlier atmospheric data, with Venera-9 recording a surface temperature of about 485 degrees Celsius and pressure roughly 90 times greater than Earth's at sea level. Venera-11 and 12 followed in September 1978. These landers did not send images, but they carried instruments that analyzed Venus's soil and atmosphere. Their findings revealed the presence of elements such as chlorine and bromine, and they provided the first clear evidence that lightning and thunder occur on Venus. While the images from Venera-9 and 10 were remarkable, Venera-13 became the true highlight. Launched on October 30, 1981, Venera-13 and 14 were upgraded versions of the earlier landers. These probes could capture images and were also equipped with advanced acoustic instruments capable of detecting the sound of Venus's wind to measure its speed. Venera-13 transmitted the first color images ever taken from the surface of another planet, sparking deep curiosity among scientists about how Venus's landscape had formed. It also used a drilling arm to collect soil samples, revealing traces of minerals and elements that helped researchers understand the planet's geology. In addition, the probe recorded sounds from the Venusian environment, producing eerie yet fascinating audio of the planet's natural conditions. The mission confirmed that Venus has extreme surface temperatures reaching about 457 degrees Celsius or 855 degrees Fahrenheit, reinforcing its reputation as Earth's blazing twin. Scientists had hoped to detect quakes using the seismometers on Venera-13, but no seismic activity was found. Venera-14, identical in design to Venera-13, also performed impressively. It returned clear, full-color photographs and used its digging arm to study soil composition, revealing details about the planet's volcanic history. In an interesting turn, the lens cap accidentally fell right where the soil compressibility test was to be performed, giving scientists a unique chance to study how it interacted with the surface. All of these operations were recorded in real-time audio from the planet. What you hear are the authentic sounds of Venus, captured for only the second time after Venera-13. The audio includes the probe's landing, the removal of its lens cover, the mechanical movements of its instruments, and the soft rush of Venusian wind. It is both haunting and thrilling to hear the voice of another world. The final phase of the classified Soviet Venus program involved missions that mapped the entire planet from orbit using advanced radar systems. Venera-15 and 16, launched in 1983, carried no landers but instead brought highly sophisticated radar imaging equipment that could penetrate Venus's thick cloud cover and map the surface in unprecedented detail. These orbital missions revealed Venus as a world shaped by forces completely different from Earth. The radar maps showed vast volcanic plains, enormous impact craters, and geological formations that suggested a planet-wide resurfacing event in Venus's past. Unlike Earth, which is constantly reshaped by plate tectonics and erosion, Venus appeared to have undergone massive volcanic episodes that completely renewed its surface. The classified radar data revealed something even more shocking, evidence that Venus might still be geologically active. Certain features in the radar maps appeared to be recently formed lava flows, suggesting that Venus's volcanic activity might be ongoing. This discovery challenged the assumption that Venus was a geologically dead world, and raised new questions about the planet's internal structure and heat distribution. The radar mapping also revealed the true extent of Venus's hostile environment. The maps showed that the entire planet was covered by volcanic plains, with no evidence of the water erosion features that characterize Earth and Mars. This confirmed that Venus had been completely dry for billions of years, with no oceans or significant water bodies anywhere on its surface. But perhaps the most significant discovery from the radar missions was the detection of unusual atmospheric phenomena that suggested Venus might harbor unexpected chemical processes. The classified data revealed atmospheric compositions and behaviors that couldn't be fully explained by existing planetary science models. But the Soviet exploration of Venus did not end there. In 1984, the Soviets launched Vega 1 and Vega 2, two probes with an innovative goal. Each carried a balloon designed to drift through Venus's upper atmosphere. Unlike the surface, which is unbearably hot, the atmosphere about 50 kilometers above the ground has Earth-like temperatures and pressures. The balloons floated for several days, carried by strong winds, and sent back valuable information about the planet's atmospheric conditions. It was a groundbreaking success. For a short time, the Soviet Union was not only reaching Venus, but also exploring its skies. As the 1980s drew to a close, the Soviet Union's focus on Venus came to an end. The collapse of the USSR brought a halt to funding for large-scale space projects, leaving Venus, once a symbol of Soviet space ambition, largely forgotten. For many years, no major missions revisited Earth's scorching twin. Attention shifted instead toward Mars, while Venus faded quietly into the background. Still, the discoveries made through the Venera and Vega missions formed the foundation of our modern understanding of the planet. In recent years, Venus has regained scientific interest due to a surprising discovery in its atmosphere. In 2020, researchers announced that they had detected phosphine gas high above the planet's surface. On Earth, phosphine is produced by microbes that thrive in environments without oxygen, leading scientists to ask an intriguing question: could there be life in Venus's clouds? While phosphine alone is not proof of life, its presence has sparked renewed curiosity. If it was not produced by living organisms, it may have formed through chemical or geological reactions we have yet to observe anywhere else in the solar system. Whatever the cause, this mystery has revived interest in Venus and placed it once again at the forefront of planetary exploration. Even with all we've discovered, Venus remains one of the most intriguing worlds in our solar system. Interestingly, it may not be as quiet as it appears. Though its vast volcanic plains look ancient, new findings suggest the planet could still be geologically active. Recent radar images have revealed bright surface regions that might be freshly formed lava flows, hinting that volcanic eruptions may still occur today. Scientists think Venus might experience massive volcanic resets, where heat builds beneath the crust and is suddenly released in global eruptions. Confirming this kind of volcanic activity would be groundbreaking. It could help explain some of the unusual chemicals found in the planet's atmosphere, such as sulfur compounds that seem to be constantly replenished. Beneath the surface, Venus hides even more secrets. Unlike Earth, which has moving tectonic plates that release heat from its core, Venus shows no signs of plate motion. For decades, researchers have wondered how the planet releases its internal heat without this system. Upcoming missions, like NASA's Veritas, are being developed to explore these mysteries and reveal more about the planet's inner workings. Venus's atmosphere is equally fascinating. Its upper layers host powerful winds moving faster than 250 miles per hour, circling the planet in just a few days. Scientists are still trying to understand what drives this super-rotation. Adding to the mystery are the massive polar vortices, huge swirling storm systems near the poles that twist and shift in unpredictable ways. Another curious feature is Venus's missing magnetic field. Earth's magnetic field acts as a protective shield against solar radiation, but Venus, despite its similar size and composition, seems to lack one entirely. Without this protection, its atmosphere has slowly eroded under the force of the solar wind. Researchers suspect that this could be linked to differences in how Venus's core moves compared to Earth's. Perhaps the most captivating mystery of all is whether Venus was once habitable. Evidence suggests that billions of years ago, it might have had oceans and a temperate climate. Some recent studies indicate that Venus could have maintained liquid water for nearly 2 billion years, long enough for life to potentially develop. If this is true, Venus may have been the solar system's first habitable planet. Over time, however, something transformed this world. The oceans disappeared, the atmosphere thickened with carbon dioxide, and the planet entered a runaway greenhouse phase. What triggered that dramatic change remains one of the greatest unanswered questions in planetary science. The legacy of the Soviet Venera program continues today through new missions that build directly on the discoveries made by those pioneering spacecraft. Russia is currently developing Venera-D, a proposed mission that would return to Venus with modern technology and continue the exploration that began over 50 years ago. Venera-D represents the next evolution of Venus exploration, combining the proven Soviet approach of surface landing with modern scientific instruments and communication systems. The mission would include both an orbiter for long-term atmospheric studies and a lander designed to survive on Venus's surface for extended periods. Unlike the original Venera missions, which operated for minutes or hours, Venera-D is designed to function for weeks or months. NASA is also planning multiple Venus missions that directly build on Soviet discoveries. The Venera-D mission will use advanced radar to create detailed maps of Venus's surface, extending the work begun by Venera 15 and 16. The Da Vinci mission will drop a probe through Venus's atmosphere, following the same basic approach pioneered by the early Venera missions, but with modern instruments capable of much more detailed analysis. These future missions are specifically designed to answer the questions raised by the Soviet discoveries. They will search for active volcanism, investigate the phosphine mystery, and attempt to understand the atmospheric dynamics that create Venus's super-rotating winds. Most importantly, they will try to determine whether Venus was once habitable and what caused its transformation into the hellish world we see today. The European Space Agency's Envision mission will focus on Venus's geological history, using ground-penetrating radar to study the planet's interior structure and search for evidence of past water activity. This mission directly addresses mysteries first identified by the Soviet surface analysis missions. These mysteries make Venus far more than a distant world shrouded in clouds. It is a place rich with scientific promise. Venus captivates researchers because it challenges us to answer some of the greatest questions in planetary science. It offers a glimpse into how planetary climates can evolve and may even hold clues to the conditions that allow life to exist in the most unexpected environments. The Soviet Union's Venera missions of the 20th century first opened the path to Venus, proving that exploration of such a demanding world was within human reach. Today, with new technology and renewed curiosity, scientists are once again setting their sights on Venus, ready to uncover the secrets hidden beneath its thick atmosphere. Venus continues to matter because it drives us to push the boundaries of discovery. Its mysteries are vast, and the lessons it holds are deeply relevant. By studying Venus, we not only learn about the nature of other planets, but also gain a better understanding of Earth's own history and future. In many ways, Venus stands as a symbol of human persistence and the endless desire to explore. As we continue to study this radiant and complex twin of Earth, we may uncover answers that reveal not only what shaped Venus, but what may one day shape our own world.
Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.